policy and policy for science. I'll talk with you about what that means. It's the work that I am engaged in, especially for developing the social science part of our field and its applications. I'll walk you through also a little bit of my career trajectory to get to something like that, because it's a very non-traditional kind of role in the field of meteorology, and it's starting to grow. I know there's a lot of interest in it, so I'll share a little bit of insight from, I guess, what were, some of the early underpinnings of work coming to be in this area. With that, let me go ahead and share the presentation. There we go. Are you guys able to see it?
Give us 1 second.
Press the view on that, on the other one, you might be able to switch it.
I can just
Speaker view.
I have to move this one over.
Yes. There we go.
Is it showing?
Yes, we're just figuring out our stuff on
Expand
our
the
end.
size. There you go.
Drag the screen up to, drag the top of the bar up to the top of the
I
monitor.
just did.
Or that.
There we go.
Yeah.
Uh-huh.
Just.
You might have to just minimize that one. Oh, I did it. Oh, technology.
Oh, technology. Yes. Okay.
We're trying to.
So go ahead.
Oh, you're good. You're good. We're just trying to get you on the screen with this presentation.
Yeah, this thing game really.
Because we have double monitors and it's very confusing. So,
We just.
okay, I think we should be good. That can work.
All right. Is everybody able to see in presentation mode?
Yes.
Yes.
All right. Then I'll go ahead and get rolling. So this presentation, like I highlighted for you, is about building a career in this policy for science area and in science communication generally. I do work for the National Weather Service. My job specifically is in the national centers. I work for the Office of the Director, that's Mike Farrer, and for an organization within the Weather Service called NCEP. So this is the National Hurricane Center, the Space Weather Prediction Center, SPC, NHC, like all of the big centers that you hear about are offices that I support. And my job now, it's sort of a first of its kind, was just created a couple months ago, but was created to help seed social science research into operations. So it's super cool. It's really awesome. Last week I was in Boulder doing stuff with space weather communication for satellite owners and operators with all those like CubeSat satellite constellations. And there's just so much to do in this area of work in the field, and it's a very exciting time to be in on it. So let me tell you a little bit about it. First, I'll start by talking with you about science communication and what does it mean to have effective science communication. A communications scholar named Baruch Fishoff, he's like very well-regarded risk communication scholar, wrote for the Proceedings of the National Academies of Sciences in 2013 when a bunch of people sat down to deliberate over what is effective science communication. And he put this succinct definition forward, that effective science communications inform people about the benefits, risks, and other costs of their decisions, thereby allowing them to make sound choices. I highlight a couple of things in there that I took away as very, very key. This doesn't say that our job is to cajole people, persuade people, like we're not here to scream from rooftops, not necessarily at least, if there is a capacity to inform them about the risk itself and its consequences. It gives them what they need to make the decisions they think are best for themselves. So this definition very much sets forward an idea that in science communication, it is our proper role as communicators of the science to help people to make the choices that are best for them and recognize their agency in those choices. It also notes, he also notes, even the most effective communication cannot guarantee that people will agree about what those choices should be. So you'll often see this be the case in our field, and I'll get to this in more depth in a minute. But you can often see after any given weather event this sort of wringing of hands about, well, people didn't do what we told them to do. There's a really important question in there about, does it matter what we thought that they should do? Is that our sufficiency condition? Is that how we know we've done our job as communicators? And there's a little bit being fleshed out about that live right now. There was actually legislation put forward 2 days ago that continues to refine this, and I will show you guys the whole story leading up to where we are. The report also notes science communications that fulfill this mission have 4 interrelated tasks that they need to perform. 1, they need to identify the science most relevant to the decisions that people face. So just slamming people with definitions of vorticity, not relevant to their decisions, kind of overshoots, but helping them understand that a system could have really strong impacts because, okay, so there could be strong rotation here that increases our confidence that the hazard will exist, like a severe storm tornado. That is decision relevant. Then you need to think about, well, what do people already know? Are people coming in with some baseline amount of knowledge? It's not just, again, slamming people with science just to slam them with it. Our objective as science communicators is to help fill a gap. And then in task 3, we can design our communications that fill those critical gaps between what they know and what they need to know. And in that, we say, like, we're as science communicators, we don't just start with the science. We have to start with the people we're serving. We have to understand their context, their thinking, and how we can reach them, what kinds of decisions they're looking to make, and then bring in the science in a tailored and curated way to help address their needs for improved decision making. And our last task is that we should evaluate, okay, well, after real events, how did we do? So this means, in sum, the sciences of science communication are really social and behavioral sciences. And I'll draw a distinction between 2 other kinds of terminology that are important. You see different kinds of terms thrown around in risk communication space. And I mentioned earlier that I work a lot in policy for science and right now also kind of science policy. So I'll describe what these 2 things are. Science policy is, the so-called evidence-based policymaking. You hear about this, a lot in different kinds of science circles. We want people to make decisions based on the best science. So that's where science policy tries to come in. Use science to inform the policy. Use science to help people make decisions about their risks, for example. You see this play out in a lot of different kinds of risky choices, from nuclear energy to climate change and everything else. That there's this line about, well, science policy believes that we should make those choices based on evidence, the kind of evidence, especially being scientific in nature. There's also a policy for science that goes on, and this is where I am most fascinated. How do we develop the science that we have anyway? What goes into, like, the values that we bring to the table to generate the questions, the things we wonder about? And a lot of what has gone on in the science of meteorology, there's been a lot of policy that's placed emphasis on developing certain kinds of capacities, maybe instead of others over time. And how can we trace, what has developed and what still needs to develop, and work intentionally in those spaces where there's still a lack of something that our science needs. For my whole career, I have felt that social science is that area that really needs that support, better definition of what it is and what it can contribute to our field, and then, more intentional places where it plugs in to our field. So I'll describe a little bit now about my background. How in the world do I get into work like that? I started out not too far away from all of you guys. I was in Indiana. I was actually born in Illinois, but then moved to Indiana later in life. Purdue was a wonderful place to go for meteorology. So while there, I was already interested in both meteorology and people, and they didn't have a marketing program. I would have been really interested in pursuing that if they'd had it. But they had economics. And so I said, okay, well, I can at least start down this path of trying to understand decision making. And I had no idea what I was going to do with it until there was a summer research internship that I did here in Oklahoma with a scientist at the National Severe Storms Laboratory, Harold Brooks, and an economist who was here, Dan Sutter, and they wanted to study the economic impacts of tornadoes. And I just thought, how perfect is that? That is both of the things together. That's awesome. And after that research experience, I found that I loved research and wanted to pursue that intersection. And there just weren't a lot of places doing it at the time. Oklahoma was a really natural fit. So after that, I came back to OU for graduate school. And at the time, they had a master's degree that they were testing out. It was intended for people who were going to go into the private sector, but I kind of co-opted it and turned it into an academic track, MS anyway, but they called it the MS of Professional Meteorology. And I stayed at OU and pursued a PhD in geography. And geography I found to be probably a better academic home for the PhD level stuff that I was looking to do. And I could have a whole conversation with you about, man, was I going to do a PhD or not? I was torn about every single step of these decisions were enormously stressful. So don't think that this was an easy path that I just happened through. In hindsight, it all looks great, but most of the time as you're living your path, it feels like a disaster that you're just kind of managing as you go along. And that was definitely true for me. But at the end of the day, I did find geography, and it is a great blend of physical and human perspectives that really just I thought was important for bringing in more ways of thinking about what we were trying to do in the field of meteorology and to help grow it. Through that process, I studied how people responded to tornado forecasts and warnings in the real world, and also how potential new technologies on the horizon, especially probabilistic technologies, might be interpreted and maybe improve decision making for people across the country. And doing that work, I learned that the National Weather Service, it had no ability to even hear what I was saying. Like, they were interested in my research, very interested, but they had no capacity to implement any of the things that I would recommend as better communication practices, because they didn't hire social scientists. They were physical scientists. And why would you expect them to have any idea how to wade their way through my research to actually figure out the implications of it? That made me think, okay, if I need to change NOAA, if the actual goal here isn't just to do science for the development of policy, but to do policy for science, how should I learn how to do that? Who do they listen to? They listen to Congress, the people who fund them. So after the PhD, the AMS at the time, they funded a congressional science fellowship that's administered by the American Association for the Advancement of Science, AAAS, very well-regarded science organization in DC. And I worked in the personal office of a senator, and in that role, learned so much about natural hazards policy and funding law and everything else. And after that, all the people at NOAA headquarters who I'd been sort of petitioning to develop this capability, they came to me and they said, okay, now that you've gotten this experience, we think you better understand our constraints, and also maybe can help us plug in a little bit better. We know that we need this stuff. We agree with you. Help us make it happen. And so from there, I went and worked at NOAA headquarters for several years as the first social scientist in what's now the Weather Program Office. During my time as starting to work in that office, I started out as a postdoc. So I was UCAR affiliated, just like I am now. And as such, as not a federal employee, I was able to do things like come and provide congressional testimony as sort of an independent social scientist. Because at the time, NOAA didn't have any cognizant social science officials to give testimony on this topic. I was the closest thing they had. So I was part of a hearing to look at how can we better communicate weather to enhance commerce and safety. And in that capacity, I started to give input on what became the first iteration of what's known as the Weather Act. I'll come back to this in a little bit more detail, because that story carries forward to today. But let's pause a little bit and talk about social science in the field of meteorology. And, is this just a recent idea that was just born in the last couple of years, popularized? The answer is actually no. there was an early recognition of the needs of different populations and calls for the inclusion of social scientists in severe weather operations starting as early as, and probably earlier than in hallway conversations, but at least in written reports, as early as the service assessment for the Palm Sunday tornadoes of 1965, where they mention, hey, what we should be doing is occasionally surveying people to evaluate, whether our forecasts and warnings are having any effect on people. What a great idea. And then there was a really awful tornado in 1970 that hit Lubbock, Texas, and primarily affected non-native, non-English speaking populations. And they had a lot of fatalities in that Spanish language population. We, of course, are talking about this a lot in our field today. Actually, one of my former graduate students, Joseph Trujillo Falcone, is a huge, sort of front runner in getting this part of the field and their act together. But when I showed him this, you should have seen his jaw drop to the floor. 1970, they were talking about it, and now it's like 2020 something. Yeah, 50 years. It took 50 years to get around to it. So why? Why did that happen that way? What was the arc of the policy for science that brought us to where we are? So while there were some of those calls put into occasional reports, by and large, the paradigm of the field of meteorology was its communication paradigm was derived from the military. I can't see any of you right now, just like you guys are having trouble seeing me, but in person, when I give a talk like this, I like to have people raise their hands if they recognize these people. You may or may not, but these are two members of the U.S. Air Force that actually came up with the first tornado forecasts. In 1948, there was a tornado that hit the Air Force Base just 4 miles up the road from me, hit Tinker Air Force Base. And they had, before that, they had put together a couple of atmospheric parameters that they looked at and said, well, maybe this will have the convective potential energy and some of the dynamic properties that could produce tornadoes. They were doing some of that early work to determine environments that were suggestive. It was sort of the proto-SPC convective outlook concepts. Well, that forecast that they had internally been chewing on turned out to be right. And they had then 5 days later another setup that was exactly the same. And they warned that time, they actually warned the rest of the base, and the base took action to mitigate loss of planes and all of that. And if you could believe it, there was a tornado that hit the Air Force Base again 5 days later. The odds of that just very unlikely, but they fared better the second time, having had the opportunity to mitigate. And after that, military really featured significantly in the field in so many ways. A lot of our technologies, radar technologies, we get from the Navy, decommissioned technology, and so on. So we get a lot of these folks who have a particular view of human behavior. By and large, it is a command and control paradigm. They assume scientists know what's best. These scientists also assume that the meteorological hazard itself will carry obvious implications for the ways people should behave. And scientists measure their success in really limited ways with things like probability of detection and false alarm ratios, maybe total numbers of death, but then also this anecdotes about, did people comply with what we told them to do? When we issue warnings, do they do the things that we think that they should be doing? And this was a very dominant philosophy in our field until just recent times, when especially the tornadoes of 2011 occurred. And this was the cornerstone of a new paradigm, because we had excellent forecasts and warnings that day. As we, similarly sort of had a month later for Joplin, there were more complexities there, but, we had all of the tornadoes that hit the Southeast in April in April of 2011. And then May of 2011 have this terrible single tornado that killed more people than we'd seen killed since 1954 in a single tornado. Things we didn't know were possible anymore. And that finally broke, I think, a lot of people in our field. And they just kind of said, okay, we need to do something different. What is it that we need to do? And from this, a couple of different programs were born. One was the Weather Ready Nation movement in the National Weather Service that began to center and include social science voices. At first, very much on the fringes of the room. I was in those workshops, like they were like, we need you, but here are actually our problems. And we kind of looked at them and said, nope, we don't agree that those are your problems. And there was a lot of like cajoling that kind of went on. But to their credit, they really, really listened to the social scientists. And after that, there was a program called Vortex Southeast that sprang to life to think about, tornadoes are especially lethal in the Southeast. And why is that? And this was Congress actually stepping in to our field to do some policy for science work. So if you're interested in the Vortex Southeast concept, now I will say, when Vortex Southeast was first floated, you should have seen and heard, even me, like there were a lot of people who looked at that and said, that is ridiculous. We cannot chase tornadoes in the Southeast. What are you doing? But the members of Congress, especially, there were very powerful appropriators who were from Alabama and Mississippi. They wanted this prioritization to shift from the tornado phenomenon and observing it to the people and looking at them. So the first iteration of language to put together this program, the House sort of centered on, okay, why is it that this area has more deaths per capita? And the Senate language was like, well, are there different variables and conditions that the tornadoes have? Like, are tornadoes worse here? And so they were both kind of, they both were interested in the region, but they took different stances on like what the approach was going to be. These were two sort of different visions. This is just a mini aside here, but if you're not familiar with the Southeast tornado problem, it was something that prior to Vortex Southeast happening in the meteorological community, we knew what was going on with that region. This graphic shows the U.S. fatality rate over time. And so this is a way that you can sort of think about how we're doing when we don't go back. Well, as I'm trying to think of a clean way to describe something Harold Brooks would say here. This is where this figure comes from. Generally, look at the line at the left side of the graph. It's sort of at about 1 or just over 1 death per million population. Over time, starting in about 1925, which was the tri-state tornado, and also the introduction of radio and other technologies for broadcasting tornadoes. So maybe there was something just happening with people talking. But before the National Weather Service even existed, there's this steady decline in the fatality rate per unit population across the country. And this has, it went on until about 2000. And then from there, we sort of have started to flatline. But on the right side of the figure, you'll see two different kinds of dots. The dots that are unfilled, that are just white, that is the fatality rate for people who live in permanent structures. And the black dots, that's the fatality rate in a given year for people who live in mobile and manufactured housing. For people who live in mobile and manufactured housing, you can see that the fatality rate is essentially completely unchanged since before the Weather Service existed. It's essentially, that everything that we've done, everything the system has done to date has advantaged one group of people. And that is people who have more resources, better resourced people. And for them, the fatality rates some years are almost nothing at all. And where are mobile and manufactured houses concentrated? In the Southeast. So when tornadoes happen here, we know that they're even weaker tornadoes are more likely to kill somebody. In fact, it's so rare that a weak tornado kills anyone that if someone is killed in a weak tornado, your bet is really good that it happened in the Southeast if you didn't know anything else about the event. So this is what, the legislators were sort of intuiting, that there was, a piece of vulnerability, the social vulnerability to their area that was important to determining the tornado impact. You look at the plains, the Great Plains, And sure, we, have a whole lot of tornadoes and there've been spectacular field campaigns, but everywhere that we'd go, that's not where vulnerable people live. And, so there was just a connection that they felt wasn't being made. And then when they created this program, they were really drawing us to think in a different way. At around the same time, then there was the Weather Act that came into the world, and this is the bill that I'd been giving congressional testimony to inform. In this, we start to see a maturation of broader ideas about what the system is for, the communication system. What is it that we're trying to accomplish? One thing that you see in the early language is, hey, what we're trying to do is reduce the loss of life due to severe weather events. We need this to stop. And an interesting feature of that edict is those of us in the social science community actually saw that. And we were concerned because there of a lot of reasons, but I mean, one, it's just the Weather Service shouldn't be held to that standard because we don't control the outcome to a large degree. When you're talking about a huge fraction of the population, sometimes over 50% of the housing stock being mobile and manufactured homes, these are chronically under-resourced areas. They don't have access to better shelters often, and you're talking about people who also, might be working 2 jobs to scrape things together. Like they might also not have free time the same way that other people do to take protective action. There's so many barriers to the process being completed that, gosh, holding yourself to this kind of standard as a way of gauging your success, that's a tough thing. And you're also, if that's your only thing that you care about as a weather service, you are really motivated as a communicator to be very pushy, try to go for persuasion, even coercion, to get people to obey your life-saving, quote unquote, messages. After that, I worked with them to massage the language some, and I really worked this out, especially with a couple of people in the Senate that I'd known during my time as a staffer who trusted me. And I suggested you really need to say that it's going to inform action to prevent loss of life and property. That should be our standard, that we, as good science communicators, that's what we do. We're not making the determination for them. We're not pretending that we're God and that we control their circumstances. The sweet spot really should be that we're informing action to prevent loss of life and property. So this got put into the final version of the bill, and there were other pieces that they told NOAA to pursue. Well, hey, you should have research on some of this. Tell us a little bit more about the social science. Bring that social science knowledge in. What does it take to bring it in? And around that time, I was at NOAA headquarters, like I'd mentioned earlier. In the office, we thought about that. Well, how do we identify, how do we try to think about bringing social science in? What exactly do we need to do to improve our infrastructure? And in that, there were a set of different recommendations made. But one was to think about our existing research organizations, like where I had been in Oklahoma. Part of what made Oklahoma special and willing to have someone like me is that there was a cooperative institute here that in its mission, it had social science as one of its key research themes. And so they were able to accommodate it just organizationally. They were like, yep, we'll let that in the door. That's something our people work on and do. And that it turned out to be really important. And after that, I thought, you know what? I have had a good time at NOAA headquarters, and doing this policy for science piece is really interesting, but I feel like it needs to be demonstrated that you can have a real robust social science capability in a research organization, like a weather research organization. I'm going to go and just show what this could look like. So this is the research theme that made SIMS now CIRO. Changed acronyms, but it made it possible to bring this work in. And I formed what's called the BIU, the Behavioral Insights Unit. And in that, we had two major things that we were doing. One, we connected ourselves to the Vortex research program because Vortex was actually run through NSSL. The funding from Congress came here to Norman, and there were program managers here who were administering it. And that included the social science portfolio. So I was able to hire somebody to be sort of an actual social scientist advising that program. And we were also interested in this piece about improving the communication of forecast uncertainty, which tied with other research going on at the lab. Now, something that's important to understand that informed the work that we did here at the lab that I just left to go to the Weather Service, but this background was so great for me coming into operations. What we did was we recognized that the Weather Service, they can have this life-saving mission all day, or their mission to inform decisions. They put out products and all kinds of communication. At the end of the day, it's not going directly to the public for the most part. Most people don't have weather radios. They're not just like scanning for waiting for the National Weather Service. They don't even necessarily know that there is a National Weather Service. They certainly don't know that we have 122 offices spread across the country, like the whole structure, that there are national centers. No one knows any of that. They're getting information primarily through broadcast meteorologists. We find in post-event study after post-event study across every hazard, broadcast meteorologists, so incredibly important. And they also are getting incredibly important guidance and even sometimes orders from local officials, like emergency management officials and other officials. And that then gets to them. So our information is what we call in the social sciences fully mediated by these other communicators. So if we're wanting to evaluate how successful the Weather Service is being, we have to look at our partners and whether they are getting our products and services, understanding them, and themselves passing them along. So what we did at the lab is we set up a system based on the principles of what's called user-centered design. We'd have developers, people who are creating incredible models and other technologies who would think, hey, this might be something that would, help someone in some way. They have this spongy idea. And we'd say, okay, well, we've got to identify the universe of people who we care about first, who are going to be the users of this. And so we understood it to be these sort of core partners that would want to start with first. And we'd bring them in to field that idea and research it, do some use cases and develop prototypes eventually, like workable things so you can get users in a place where they're, really trying to simulate in the real world. What decisions would I be making? And how would this technology change how I do that? And would I pass this information downstream? And then we just go in a cycle of, okay, this worked, this didn't work. And doing that, there were a bunch of different kinds of technologies that the lab had been developing that we helped them to just think differently about. We helped them to just understand assumptions that they were making. They weren't going to work in the real world, but we returned ideas to them that they could use to tailor some of their technologies. And what's great about this is this process kind of ensures that you're not just creating technology and shoveling it out the door and that you're unsure if anyone will use it or understand it at all. But you can try to tailor the science to address a specific set of needs. And if you look back at what I showed you for like the Southeast or before that, the tornado fatality statistics, you could think of that as just an extraordinary, generations long design failure that we didn't have any specific person in mind. We were really kind of just throwing out technology that was created generally by military-minded people for people who were generally well off. People who came into the field of meteorology early tended to be like sort of upper middle class and white. So you create what you think what you think might be useful, and it'll end up being useful to people like you. Our field, by not being extraordinarily inclusive and diverse, was sort of limited in its vision for the science and in its whole process of creating the things that will go into our communication system and inform decisions. When I look back on it that way, I think it's no surprise that we have overlooked vulnerable populations. But the way we can unlock the path forward is through changing the way we do our science, and user-centered design principles are key in that. So moving ahead to just last year, there were a couple of little craftily named acts. There was like a flood act, a tornado act. The tornado is actually an acronym. That's why it's like it looks like it's shouting at you. There's some congressional staffers who were really proud of themselves for this, I'm sure. But the idea was they were going to put out different pieces of legislation, knowing that the Weather Act had been passed in 2017, 2018. It needed to be what's called reauthorized every 5 years. So it was passed in 2017, like late in 2017. I think it came into effect in 2018. We're at the 5-year mark where we're considering that reauthorization. And so they were preparing all of these bills ahead of time to sort of think about, well, what are our priorities now? And in the intervening 5 years, since they started, they laid down sort of, okay, we want to inform decisions. Now they're getting more specific with the Weather Service about some of the things that should include. And you can see that early language has bits in it like, hey, we need to clearly inform action, but also increase the likelihood that the public is going to take, action to prevent loss of life or property. I appreciated that inform action survived, but I was, like the likelihood that they'll take action to prevent the loss of life or property. At least it's kind of an either or thing, but yeah, I still thought, measuring action is kind of a difficult thing for us to say that we've, done the thing we need to do. But it does at least suggest, hey, we want you to evaluate. We want you to actually get more data, understand what has gone on, evaluate the communications plans. Like they said in that service assessment report in 1965, that you should periodically do surveys to figure out if your communication systems work. Hey, Congress finally getting on the bandwagon with that 60 years later. Maybe they'll actually give us the funding to do it too, but at least they're putting it into authorization language that they want us doing it. And, as part of that, they want us to do things like account for the needs of different kinds of people, vulnerable populations, different geographic regions, understand the people you're serving, try to get a little bit more granular. And I'll just go forward to what there's been more massaging. I had more conversations with more people. All of those little cute acts got put into this bigger, they sort of informed and little pieces ended up in the new Weather Act. And the House just introduced their version of this bill on Monday. So you can look up the full text for it if you're interested. It's kind of an interesting read. My big thing I tried to do was through all these sections, put in that informing decisions, informing response, just that is our line. That's the gold standard of risk communication. That is what we should be doing. There had been some earlier language, like when the first iteration of the bill came out, it was so like all over the place. Like, but the physical scientists and the congressional staffers just aren't paying attention to that piece because they're so focused still on this fairly militaristic understanding of human behavior. And I'm trying to just keep them, in this idea of people can make good choices for themselves. They're the ones who understand their situations. This goal is very, very important because the history of the field of meteorology, it's really filled with us trying to push people and then being very judgmental when they didn't do what we thought that they should do, often because they couldn't. And anyway, that's a whole high horse, obviously. But I was very pleased in this language. It did come out. I was able to make those modifications. I was able to successfully defend the case and inform response. And so made it through here and in other places. So I'm really excited about this version of the bill. I think that it includes a lot of really awesome things. And looking back over the career that I've had and the things I've gotten to be a part of, and I've had this I've been trying to just care for this piece of our field and find ways to get social science in different places. In NOAA headquarters, I was making that role and thinking about what can a person do at headquarters to help guide policy. And then at a laboratory, how can we create a research group that does this work to inform our communication strategies? And now in the National Weather Service, I'm thinking about how can we take that research and actually implement it in operations, the other side of that coin. And watching this happen is so extremely rewarding and edifying. And it's just sort of a beautiful conclusion to that whole process. So with that, I will wrap up that part of this and just see if you guys have any questions or comments. Thank you again for having me.
Anyone? Andy,
I have one. She can hear me from here, right? That works.
can you hear him?
Sorry, try again.
Hi, are you able to hear me from here or should I get closer to the microphone?
I can hear
Okay.
now.
Good. So I think maybe the answer was sprinkled in here and there and over dense legalese and all that, but I'd like to hear it in your own words. Where do you draw the line between your responsibility to inform people and the people's responsibility to like actually care? Because on one hand, like if someone, was just completely like not knowing and lacking, it might have been your fault, but you can't really also save someone who doesn't want to save themselves. And I'm saying this as a person who has a father who wants to sleep through tornado sirens.
Yep. No, what you have just articulated is why this is so important, because every person in our country has different risk preferences. There are some people who, it's a sacrifice to constantly be on high alert and to constantly be ready to shelter and whatever. And there are some people who don't want to put their emotional effort there. We live in a world that is constantly trying to tell us everything is a risk, everything is a threat. And that does take a toll. I want people to survive tornadoes. I am here for us putting out better information and all of that. But there's a part of the population that we shouldn't be trying to tailor our messaging strategies to reach people like your dad, because then we'll be motivated to do super crazy things like hit people over the head with "you're gonna die" warnings. Like,
Well, I almost did that.
So what?
I almost did that once. It almost became physical before I finally showed him the velocity and he's like, fine.
Now, see, your role as a son, totally different from our role as a National Weather Service. So I think it's totally fine for us to do that for our own family. And that's really, really effective. But it shouldn't be public policy. Great question.
Thank you.
I have one. I'm trying to think how to say it. I think I have one. I'm trying to think of how to say it. Hello. I want to like piggy off of what he said. I know we're trying to reach out to like more people like with this bill and stuff, but it's like how do we like use like nicer language or whatever to like not super cautious, but also like do you combine it with like increasing technology so it's like more accurate rather than, because people always complain here. Literally last year in during the March 31st thing, March 31st tornado event that went north and south of us, everyone was complaining about it completely missing us, and there was a tornado warning. Like, no, there was a high risk and everyone was talking about it. So sorry, I went too long, but what do you think about that?
No. Okay, so what you're talking about is it's a whole other talk that I give on the importance of communicating for uncertainty better. So, at heart, what the SPC does when we put out things like high risks is we're saying, like, we're giving one potential forecast future and placing our emphasis on it. And yes, SPC has probabilities underneath that, but we're not saying like, hey, this could be super catastrophic, but there's also a kind of chance that nothing happens, which is actually really common on high risk days, by the way. They have the biggest boom bust potential because they're so volatile. And if we were able to give people a better sense for like the day could be like this or like this, all the way down through time to, hey, the environment you're in is getting like more favorable. Things between a watch and a warning. And then with the storms that come through, actually offer, like this area is looking like, could be really you, this area less, like giving people more of that information helps them to make better decisions. And when we're more transparent about what we know and don't know, then they also trust us more. So if you're under warnings and nothing happens to you, and that's all you got, like if a warning technically means, yeah, tornado is it exists, it's heading your way, like that's what we try to get people to think about it, then yeah, you will be upset if you don't understand the underlying uncertainty that was there the whole time that we have in our heads, but we're just not conveying. And that's what probabilistic information, we hope, will do in the future.
Okay.
Interesting. I think I heard about a talk last year at AMS, at the annual meeting, about somebody talking about using different language, instead of slight or, marginal, because it doesn't mean anything. It's not a tangible number. And so it's kind of great to connect everything together right now. So
Yep. And that terminology piece is definitely connected. We know that people, like the research that you're talking about, is showing us that people don't put those words naturally in order, and that can be a bit of a problem. The SPC, though, is also thinking about, well, our scale isn't just linear. And by that, I mean, look at like the Saffir-Simpson scale. That you can say, okay, there's chunks of like wind speed is increasing, or, look at seismicity with earthquakes. That scale, it's, exponential, but the magnitude of the force is like what's scaled in there. But the SPC has two aspects that they're scaling in their scale. One is the like sort of density of tornadoes. How many tornadoes will there be in a given area? So that's called coverage. And the other piece is potential intensity. And there are some days, the reason why they expanded from 3 to 5 categories and made this whole mess is because they knew that there were some days that were slight risk days by the number of tornadoes that could occur. But if stuff really did get going, they could be very bad tornadoes. So they were sort of this upper end slight. They actually enhanced that. Enhanced is it's hear me?
oh no, sort of.
It's
kind of
cutting
breaking.
out.
Cutting out.
Oh. I think the demo will got her.
All right. Is that all better? Am I
We can hear you.
We can't
You're
see
just
you.
frozen.
You're just frozen.
frozen? All right. Let me just really quickly see if I can change my stop the video and then reboot. All right. Is that better?
Yep.
All right. Technology, right? So there's this question, like we had enhanced because it means enhanced slight. It's this upper end slight where, okay, we still think it's going to be a few tornadoes, but they could be real bad. This isn't a linear scale. It's like two different factors that are going up. We don't just need people to understand the difference, like to put them in order. We need people to know that, hey, there might not be a whole lot of tornadoes today. It might not be you, but if it is, like these tornadoes could be really bad. It could be a situation that is actually really worth, evacuating a mobile home for. If a storm is heading your way, you'll really want to take this seriously. So there's a lot that we're trying to work out there. Trying to slam everything into just one scale can sometimes be really, really like insufficient, or you can highlight the wrong thing. I'll look back at Saffir-Simpson scale. Actually, across all of the national centers that I'm working with, they're all questioning their scales right now. the National Hurricane Center, the Saffir-Simpson scale, wind doesn't drive like any of the impact to human life. For the most part, people die in flooding. They die in surge and they die in inland flooding. But we scale everything based on wind. That's really misleading when you've got like a Cat 1, but it has monster surge because of the whole history of a hurricane going up a basin. That was a hot topic after Superstorm Sandy, when it wasn't even classified as a tropical system when it made landfall. We made this big distinction of, oh, it's now this extra tropical, like that didn't matter. It didn't matter. People died in the flooding from a very, very intense cyclone. And so they're rethinking how they're messaging the multiple kinds of hazards in that and whether that kind of scale that they're using now is sufficient or if it should be changed. And that's a really important question. We need to be thinking not just about the words we're using, but what's behind those words. Are we talking about the right variable at all?
Oh, didn't even think about that, yeah. Any other questions? No? Thank you so much. I appreciate it. I appreciate the speech.
Yeah, thank you guys. I really appreciated being able to join you this evening. I hope that you have a wonderful rest of your fall semester.
Thank you.
We'll try. Thank you.
Bye, everybody.
Bye.
Hey, guys.